Hello, everybody, and we are live. Welcome to today's episode of Amazon's Fireside Chat. My name is Anisha, and I'm joined today by my lovely colleague Mario. Mario, do you want to say a quick hello?
Hey guys. Hello, hi everyone. For those that don't know me, I'm Mario and I work with Anisha in the Amazon Devices Developer Relations team. And for all those that are back watching the live stream, hello and welcome back.
Welcome back, guys. So cool. Today we have a really cool topic. We're going to be talking about, let me get it on screen, designing great Android apps for tablets. So if you joined us last week, we were talking about security and testing. So we thought we'd switch it up a little bit and go back to talking about tablets and how we can design great tablet apps. So before we jump in, a little bit of housekeeping. As usual, make sure you join the chat, engage with us. We love to hear your questions. We want to hear from you. We want to know what you want to know, so we can do our best to answer your questions. We're here every Tuesday at 6 o'clock. So join in if you're not already joining in. Tell your friends to come, family, bring everybody. Second rule and what we hope is everybody be respectful. So in the chat, just use respectful language. We want to make sure we're creating a great environment for everybody to feel comfortable and ask questions. And don't forget to follow and subscribe. We're here every Tuesday. So if you subscribe to our channel, you'll get a notification when we go live. I'm sure you're going to be excited to see the topic we have today. So without further ado, let's jump right in.
Amazing, Anisha. Thank you so much. And I think we can maybe share our presentation that we have prepared. Wonderful. So again, today we're touching one of my favorite topics, which is design. And specifically, we are here today to talk about designing great Android applications for tablets specifically. So we will jump in and see specifically what can you do as a developer and as a designer to create what I would call pixel perfect applications specifically designed for tablet. Next slide, please. So first of all, let's talk about the variety of devices that you can build for. As you know, when it comes in particular to the Amazon App Store, the Amazon App Store actually powers a variety of devices. It powers Fire TV and Fire TV Stick. We had already a lot of content that we have shared about how you can create great applications for the big screen. And of course, it also targets Android phones and tablets. You can actually build Android applications run on the Amazon App Store, and the Amazon App Store is available for download and use on pretty much any Android phone and tablet. And one thing that we announced recently is the fact that Amazon App Store is also powering now Android applications on Windows devices, and in particular on Windows 11. And when it comes to designing for those type of devices, we kind of already shared a lot of content, but there is another device that is extremely important, and I would say in the roster of Amazon devices is one of the most popular devices, which is Fire Tablet. So now it comes natural the question, why designing for Fire tablets? Why building applications for Fire tablet? So, and there is one easy answer to this, which is next slide, please. Which is the fact that there are actually millions of these devices out there. Here's a quote from Kevin Keith, with his our GM for Fire Tablet, which is the Fire 7 is our best-selling tablet with tens of millions sold. So there are millions and millions of customers out there using Fire tablets every day and consuming content, playing with apps, playing with games. So the opportunity is huge when it comes to making content available for these devices. But now the question comes, how can we design applications in the right way for these customers? To use a quote from Mark Bolton, a designer, to push the boundaries, we need to know where the edges are. So, to paraphrase this, we need to understand what are the intricacies of building pixel perfect applications in order for us to then deliver a great experience um, to our customers. So during today's presentation, we will go through some of the aspects of developing and designing applications for tablets that you need to take in account when you are not only releasing, but even before architecting your application for these devices. So I will now switch over to Anisha, which will navigate us through some of these aspects. So Anisha, please, all
Yeah,
yours.
definitely. So we said we'd speak about different techniques and things you can use to design these great Android applications. And the first, and I would say like the easiest one to implement, is to use a flexible layout. So if you design your app for a specific device's screen, it may both look and behave differently than you expect it to run on a device with a different screen size, aspect ratio, pixel density. And don't worry if like you don't know what all these things are. We will jump into more detail about how you can think about all these different things like pixel density, aspect ratio. So, what a flexible layout does is it enables your app's UI to dynamically scale to different screen densities, sizes, and aspect ratios at runtime. So, a layout defines the structure for a user interface in your app, such as an activity. And layouts are a key part of all Android applications, not just Fire tablet applications, that directly affect the user's experience. And there are 5 main types of layouts that I want to briefly jump into. So, the first one is a relative layout. So, the relative layout, which is used to specify the position of a child's view instance relative to each other or relative to the parent. So, you can align your child view to either the top of a parent or relative to the parent, i.e., like say I want it to the left of element A or the left of element B. The second one is a linear layout. So this is a view group that aligns all children in a single direction, either vertically or horizontally. Third, we have what most Android developers are familiar with, which is a constraint layout. And this allows you to create a large and complex layout with a flat view hierarchically. So you don't have nested view groups. It is very similar to a relative layout in that all the views are laid out according to their relationship between sibling views and the parent layout, but it is much more flexible than the relative layout and easier to use in Android Studio's layout editor. So this is definitely what Android recommends to use. It's much easier. So definitely, if you're going to use something, constraint layout is the best place to start. If not, there's also something called a table layout. So this is a view group subclass which is used to display the child view elements in rows and columns like a normal table. And finally, we have a frame layout. And this is designed to block out an area on the screen to display like a single item. I don't know if there's anything you wanted to add, Mario, to that.
No, I agree with you that I think most modern Android development will start designing their XML layouts using constraint layout as probably the most dynamic. Is one that allows to avoid overlapping of items as well, and allows you to define relationship between the different items. So you can also build something that is extremely flexible. On top of like defining your XML layout as well, there is a new design pattern, a new UI toolkit, which is called Jetpack Compose, which we're not going to go into the details of Jetpack. Potentially we'll touch that maybe in a different session, because it's its own new world. But the approach should be very similar even when you're building a programmatic approach like using Compose. So the idea is that you should build relationship between the different items of your layout, and then this should automatically allow you to scale your application depending on independently on the screen size. But there are a lot actually of nuances to not only the relationship between the different items, but even the size of the resources that you use. So I think that is actually a good segue into the next topic, which is, how do we provide multiple layouts for different screens?
Yeah. And so this is like our second technique that we want to touch into. So another way that we can design an app that looks good on these different screen types is to define an XML layout for different screen configurations. So at runtime, the device reports its configuration, and Android then chooses the appropriate matching layout resources for that screen. So you can ensure that at runtime, your screen is being optimized for the screen type. So defining multiple sets of layout resources enables us in a single application to create something that's flexible and adaptable for different screen configurations. So how do we do this? Okay, there's a lot to this. So the first thing I want to do is to guide us to how to understand screen density. And this is important because this is a value we'll use to describe layout resources. So how would we define screen density? So the first thing we would think of is a pixel. So I'm going to try and explain like a little bit about what the smallest blocks are, and then get into what we would probably use to define a layout resource. So a pixel, as you probably know, is the smallest unit of a digital image or graphic that can be displayed and represented on a digital display device. This is different from the resolution, which is the total number of pixels on a screen. And each pixel is represented by a an RGB dataset value, which stands for red, green, blue. And each pixel's color sample has these three components. So each pixel is basically just an RGB value. So how do we then describe our devices? So when we describe our devices, we talk about their resolution in pixels. So for example, the Fire HD8 is 1 to 80 by 800 pixels, whereas the Fire HD10 is 1920 times 1200 pixels. So as you can see, just between our two devices, not only do they have different resolutions, they also have different physical sizes. So how would we define, dimensions in our layouts that relate to both? So as you can probably see, defining dimensions in pixels is already a problem because the different screens may have different resolutions and pixel densities. So the same number of pixels may correspond to different physical sizes on different devices. So what do I mean by this? So I'm talking about the dots per inch, for example. So not only do these screens probably have different pixel sizes, but they also might have different pixel densities. So if we look at the pixel densities on the Fire HD8 and the Fire HD10, the Fire HD8 probably has 189 pixels per square inch, and the Fire HD10 has 223 pixels per square inch. And this is the unit we use to measure them, which is dots per inch. So if you don't consider these variations in the pixel density, your device may scale your images, or the images may completely appear the wrong size or blurry because we're not factoring in these different dimensions. So how do we go about making sure that we do? We do this by creating density independent pixels known as DIPs or DPs. So to create layouts using density-independent pixels rather than absolute pixels, we maintain the scaling of the UI components. So if we have a look, if we're looking at a medium density display, which is probably 160 dpi, this would be one density pixel by one density pixel. And a high density display could be 240 dpi, but the density pixel the DIP would remain the same. So how do we calculate these DIPs? So we do this using this really important formula. So pixels are the DPs times the DPI over 160. So what does this look like for what we saw before, our Fire devices? So if we look at something that was 160 DPI, this would look like one pixel would be 1 DP by 1 DP. And if we were to look at something that's 320 DPI, 2 pixels would still be 1 dp by 1 dp. So as you can see, this gives us a really nice unit to scale with. We can also use a similar method for scaling for text. So that's called scale independent pixels, or SP, and we use that for text. But the DP units have a baseline of 1 DP per pixel, which are automatically scaled at runtime for screens with higher screen densities. So your images won't appear blurred or, the wrong size.
If I can maybe add one thing is that
Sure.
one of the main reason why we should use DPs is that it allows us to, and again, reinforcing what you were saying, is that it allows us to have the same physical size on devices which have different resolution and different density. So the interesting bit is that really helps us as developers as we are defining the resources that need to go into our applications. Let's say, for example, backgrounds or the drawables that needs to go into things like buttons or specific backgrounds for specific views, because we know what the physical size needs to be, and then we can then distribute, as we will see in a second, in different buckets these resources in a way that gracefully scales across these devices. So the bottom line is that we might have two different devices, let's say a Fire HD 10 and a Fire HD 8, but the buttons, if we were to look them side by side, the buttons on, or the views on these two screens will actually look the same size. And that's one of the great advantages of using density independent pixels. The other thing that we didn't mention here, but I think it's important to call out, is which is a good design pattern when it comes to using density independent pixels, which is to use a specific rhythm across all your different devices. So when it comes to Android, the reference rhythm is 8 DPs. So if you use 8 DPs and scale across your different devices as a multiple of 8 DPs, let's say that you have 16 DPs or 32 DPs, it helps you maintain the right rhythm across all your different units, and they will also it will allow you to build a more graceful UI as you go along and define all the different items, because otherwise you might be using, I don't know, 10 DPs here and then 12 DPs there, and then it starts to to be not the right ratios, which might impact the usability. There is a question before we move forward, actually, which is a question from Merinflow86, which is, all the information here is also transferable to Fire TV, right? So it's a good question. However, we need to take in account one thing, that is, on Fire TV, everything when it comes to UI is rendered at full HD. So you can use actually 1920 per 1200 as a reference, per 1080p as a reference for your UI. The screen density doesn't really apply that much to Fire TV. It applies way more to tablets because you have way different screen sizes and higher screen density and different resolutions. So you could have a device that renders at like we said, like Fire HD8, which is at 1280 per 800, and then another device which is 1920 per 1200. And also it's a different size. So the screen density does play a part, which is not as relevant probably if you're designing for Fire TV. But great question. Thank you. Anisha, I don't know if you want to add anything before moving forward.
No, all good. Yeah. Cool. So moving forward, so now we have a independent way of scaling. How would we define our configurations to use layouts that are, scaled with these conventions? So screen configurations can be defined using two methods and that we want to look at. So the first one is general screen size qualifiers. So these, Android defines 4 of these. So there's LDPI, MDPI, HDPI, and XHDPI. And I want to look at these in relation to our Fire tablet devices. So if we look at Fire 7, this falls under the MDPI category, and the Fire 8 is defined as TV DPI, but you could also use HDPI. That's also what Fire HD 10 is defined as. These then qualify as large for the Fire Tablet 7 and 8, and extra large for the Fire HD tablet. So when we're defining these layouts, we can put them in these categories of large and extra large. The second way we can define it is using screen configurations that can be defined using the smallest width qualifiers. So this allows you to provide alternative layouts for screens that have a minimum width measured in these DIPs. So how do we calculate that? So if we look at the Fire HD10, this has a smallest width of 800 dp. So how would we get to this value to then define our layouts? So let's have a look. So the Fire HD10 is 1920 times 1200 pixels, and it has density per inch of 223. So how do we calculate the DP? We use the same formula we looked at before. So pixels equals to DP times the DPI over 160. So our pixels on the smallest width are 1200. So to calculate the DP, we take 1200 over our DPI over 160, which gives us a value of approximately 860. So that's how we get to the smallest width 800 dp. And by describing the screen size as a measure of density independent of pixels, we can create layouts that are designed for very specific screen dimensions while avoiding any concerns we might have about different pixel densities. And this smallest width qualifier specifies that smallest width across the screen's two sides, regardless of the device's orientation. So it's a simple way of specifying the overall screen size for your layout. I think that was it for how we can describe these layouts and configurations in a scalable way. So I'll hand it back over to Mario to talk about how this plays into our Fire tablets.
Brilliant. And I see there are some questions as well. So maybe actually, since we have only a couple slides to go through, let's go through the slides and then we can go back to the question and try to navigate those. Because I think there are a couple things that I probably better to firm up before we jump in and talk about the Q&A. So thank you, Anisha. That was brilliant. I think the question now is, how do we take everything that we just learned about the different configurations and the different identifiers that we can use, and how do we apply this specifically to Fire tablets? So next slide, please.
Yep.
So how do we build something that looks pixel perfect for Amazon devices? So the good news when it comes to Fire tablets is that even though there are a variety of tablets out there in different versions, there are not as many versions as the enormous amount of Android tablets that you would find in the broader market. So the interesting bit is that there are actually only a couple of qualifiers that you can use to target the latest Amazon Fire tablet. And actually, this hasn't changed much over the last few years. Even if you go back a couple generations, you can still apply those learnings to the previous generations. So first of all, we have the Fire tablet, also called Fire 7, the 7-inch device, and the Fire HD8, which is an 8-inch device. And these two devices, you can actually use only one qualifier, one small width qualifier, which is SW600DP, to target both. So the good news here is that they share a similar density and similar resolution. And even though, of course, the Fire HD8 is bigger, one is a 7-inch device and the other is an 8-inch device, so there is not a huge amount of difference between the actual screen sizes. So you can use one identifier for smallest width to basically rule both, to rule them all. And then there is another one, which is the Fire HD10, which is a higher density, bigger device, which has a bigger display. So this one requires a use of a different small width qualifier, which is SW800DP, as Anisha has just said. But the cool thing is that just by using these two, we're actually we're targeting all the Fire tablets, at least the latest generation. And this means that we can actually provide pixel perfect resources using this targeting. However, you can also go into basically mix and matching different strategies. You can combine different strategies. So you could use, as we said, the small width qualifier, which allows you to have, two qualifiers for both. You could also use the general size qualifiers. This is a little bit more, it has a little bit more wiggle room. You can go onto the Android documentation and check out what these devices are. But basically, when it comes to Fire Tablet, if you use X large, you will target the Fire HD10. And then if you use large, you will qualify the Fire HD8 and the Fire HD7. Or you can use another category, which is a density specific category. And here you have actually three different buckets that you will need to put your resources in. HDPI is the bigger Fire HD10. You have TV DPI, which is unique to the Fire HD8, and then you have MDPI, which is the medium identifier, which targets the Fire tablet, the 7-inch device. So as you can see, there are already a variety of combinations. I think that the easiest approach is to use the smallest width qualifier, because that allows you to have a couple of identifiers only, and you can define still pixel perfect UI on both. So next slide, please. So the one thing that we need to understand is that there are a variety of ways for us to describe and to bucket our resources. So there is the approach that requires us to put assets into graphical based assets. So in this case, we need to use the identifiers like HDPI or MDPI for our drawables. So usually you create this folder under the rest folder of your project, and then you need to create a folder called drawable HDPI or drawable MDPI. For Fire Tablet specifically, you will use drawable HDPI for Fire HD8 and Fire HD10, and drawable MDPI for Fire for the 7-inch device. However, if you then instead want to use folder-based layouts, you will need to use, in this case, it's better to use the smallest width qualifier. So you can define, for example, res layout SW600DP, and that will allow you to target the Fire 7 and Fire HD8. Or you can use the layout SW800DP for the Fire HD10. So that allows you to kind of mix and match. And like, for example, if we wanted to go even deeper, if we wanted to do the graphical assets, we could actually have HDPI only for the Fire HD10. We should have TV DPI for the Fire HD8, and then MDPI for the Fire 7. In this case, it's actually okay to have your drawables for a lower resolution screen if you're providing higher resolution drawables. Like in this case, you will provide HDPI assets, which will be scaled down to TV DPI, which is lower. So it's okay only to have two buckets in this case. If you want to be more precise, however, you can provide the different three buckets: HDPI, TV DPI, and then MDPI for the different devices, which will allow you to actually be pixel perfect. So here's again a demonstration of how you can potentially mix and match the different approaches. And finally, maybe we want to talk about optimizing your icon. So iconography is very important, and the fact that you need to show icons in the right way on your different devices is something that you need to take in account. So when it comes to optimizing the icon, you want to use HDPI for the Fire 7 and extra HDPI for Fire HD8 and Fire HD10. This might sound counterintuitive, but this is for the high quality image that is displayed not only for your application, but even within the Amazon App Store. So make sure that you are providing these items at the highest quality possible, because then they will be rendered in that quality on the actual device. If you want to have more information about this, you can go on this short link, make great icons, bit.ly/make great icons, a tool to help you make great app icons, and then FireOS launcher icon guidelines, which you can find at launcher icon guidelines as well. And we have the links in the chat as well. Thank you very much, Alicia. And finally, the last thing that I wanted to share today is how do you declare support for the tablet in your application? Because the Amazon App Store will need to, and the device itself will need to be able to discern what specific layout is supported by your application. So there is a tag in the Android manifest that is called support screen, and you can put this specific screen targeting that you want for that specific APK. So let's assume that you want to have two separate APKs, one for a certain, let's say for the smallest with qualifier 600, one for the 800 smallest with qualifier. You would use support screen, and then there is, as you can see on the bottom, there is a qualifier that says Android requires smallest with DP, and there you can put in this case is 600, so it will only target 600 DPs, and then you can have a similar describer for the 800 DP that will say just 800. This way, automatically, the App Store will cherry pick the application that can match the descriptors of the actual display of a device. So it will automatically take the application that has the correct assets, the correct resolution, the correct scalability of layouts for your specific for the device that the customer has. So in this way, everything that we just seen allows you to build and render applications that really look pixel perfect on pretty much any Android device, as you've seen. But specifically, if you follow all the steps that we've given today, you will be able to target specifically pixel perfect applications for Fire tablets. So this was the last slide. I know there was a lot of information today. So one thing that I want to remind you is that these sessions are recorded, so you can always go back and check out this content. And also, everything that we say is available on the Amazon developer portal. So if you go on developer.amazon.com and check out all the specs of our devices, you will find everything that we just shared today, and actually way more. So if you want to check out more about screen size and resolution, Anisha, thank you very much. You can see the links in the chat. So that was a lot of information. I'm sure that you guys must have a lot of questions, but actually, I know that there were questions that were posted before. So Anisha, why don't we take one of these initial questions?
Yep, that sounds good. There
Great.
is
So I think that there was, yeah, great. Are there any conventions for JavaScript viewpoint with height for font sizes and layout? Great question. So I would say that the short answer is it depends. It depends on what is your, like, what are you using in terms of JavaScript to map into the Android layer. So it depends if you're using something like React Native or if you're using something else, and how does this map directly. Arisha, I don't know if you have any suggestion in this sense, but I would say that it really depends, first of all, of like how you are. Like, I think that you should consider anyway, even if you can use directly DPs or density independent pixels, that should still be taken in account when you're defining the resources that you are putting in, and then what you're putting into the layouts. Then how you're displaying that, I think that is, probably maybe slightly more of a challenge when you're dealing with JavaScript based application than when you're building native Android apps. I don't know if you have any suggestions there.
Yeah, so I was gonna say, like, in your, well, if you're using JavaScript, say with React Native, you can define, your style guide in a way that scales for very similar, like 8 dp. You could do it for scaling for 8 pixels. I know this is like quite a common practice, so you can take, I guess, the conventions that apply to, like Android development, and um translate them into your style guide that you're using with JavaScript.
Awesome. So, and Chang, hopefully we have answered your question. If not, let's follow up. I think that's actually a great question. We could do maybe a follow up, like how do we design great web applications? I think that would be a great session actually.
Yeah,
Also, let us know
especially.
what do you guys want to hear. If that's of interest, we would love to, pick up the topic.
Yeah, I think especially like now with the whole launch of, Windows subsystem for Android, it's going to be now like we're going to have to think about how we take these Android applications that probably people might be able to use as like web views, or I mean, I'm just spitballing here, but yeah.
Yeah, no, I think that's actually a great point, Anisha, about like everything that we saw today. It does apply to the context of Windows because,
Mm.
a Windows device does have a physical screen size and a physical and resolution and specific density. So, and also, which is peculiar, I would say, to Windows applications, the app on a screen. So in that case, I think it becomes even more important to build an application in a way that is flexible. Because if you're targeting Windows, then you want your single individual APK to stretch across different sizes. Because I could use an application in portrait mode, but I could use it in landscape mode as well. Probably most applications will need to support landscape. So designing for and could also be used in kind of tablet mode if the Windows device is in tablet mode as well. So I think that becomes crucial as well to define your application in a way that scales gracefully, because that is very much an important use case on desktop.
Yeah.
There is a great question. Are there any example SDK code showing flexible layout and scaling? So not so much maybe about SDK code. However, there are a lot of sample applications that you can run. Not specifically maybe from Amazon, but there are actually if you just go through the normal Android documentation, you will find a lot of best practices and sample applications that can run across different devices. It's actually a good prompt. I think it would be interesting maybe to have a sample application only for Fire tablets and what they look like, even though it will be probably very basic applications that follow what we said today. I think that could be an interesting idea. But pretty much, if you take these 2, 3, 4 learnings that we shared today, and you apply to your applications, you will see immediately. You can run on an emulator as well if you don't have a Fire tablet. You can build an emulator that has the exact same screen size and density potentially of a Fire tablet and run your applications there. It will already help you like take the right approach and measurement. But that's actually potentially an idea that we can send back to our team. Wonderful. I love that. I love when we brainstorm ideas from the community. Uh, Wonderful. Guys, is there any other question about whatever you saw today about Fire tablets in general, and anything that you would like to know about Amazon and the Amazon App Store as well? We are here as well to answer your questions. So I don't know if you have any curiosity that we can satisfy. One thing again that I want to always remember is to also use the hashtag Amazon FireSideChat on social media. So if you have anything to share afterwards, please add the hashtag here to your Twitter or Facebook or LinkedIn chat, so we can always jump in.
On that note, so I think soon I'll be sharing like tips and tricks. So like we talk a lot about different things in our Twitch and YouTube videos, but I wanted to condense it into like little bits of information. And I think the first one that we were going to share is the fact that if you didn't know, Fire tablets offer a way to split screen. So you can, use YouTube in the top and your Amazon App Store in the bottom. And this is actually something that you probably do want to consider when you're designing your Fire tablet app as well, because you're going to have to factor in the fact that some applications would be able to go in split screen. We didn't cover it today because we had so much else to cover, but if you go into the documentation that I shared in the chat, the screen layout and resolution one, there is some information on how to account for split screen when you're designing your Fire tablet app, or if you want to say I don't want my app to be able to go into split screen mode, the documentation will give you how you can define this. But it's a really cool feature, so check it out on our Twitter or LinkedIn. It should be coming soon. We have a very good YouTube video that explains how you as a developer can implement this feature.
Yeah, if it is of interest, that could be also a topic that we could potentially cover in one of the next sessions as well, if you guys are interested. There is a question: are all Fire devices able to split screen? So actually, right now, I believe that the feature is available only on the latest FireOS 7 enabled devices, but that's a feature that should be propagated to all devices and the newest models as well. Great. So yeah, if that's of interest, and thank you, Anisha, that's a great prompt. Go and check out the video on YouTube. Yeah, if you guys are interested, let us know. We would be happy to maybe show you a demo very soon as well. There is another question. This might not be related, but how about transferring an app from the tablet to the TV? Is there capability for that? Great question. So first of all, nothing stops you from building an application that works on both. I think that the challenge, well, actually, I would say that most developers, in particular, if you have a media and entertainment application, the core of the app is likely going to be the same on tablet and TV, like the engine they use, the media player, and so on. However, one important thing to keep in mind is the user experience is different between TV and tablets. Tablet is mainly touch-driven. TV, at least Fire TV for the living room, is mostly remote-based, and then yes, there is auto now where you have touch, so the experience is a little bit in between, but TV, when you're building for TV, should be remote first for sure. So I think there are some learnings there, and we shared this in some of the previous sessions that we had. So you can go back and check out some of the designing for TV sessions that we did a few weeks ago. And there is a lot of documentation on the developer portal. But the most important bit is that you should build your application with both touch and remote in mind. The idea is that the more you follow the basic Android navigation design patterns, the easier will you be if you're building a TV application then to move into a tablet application, and vice versa. Because there are nuances to developing a TV application that uses the remote, things like the focus. Like if you want to move from one view to the other, from one button to the other, you literally need to scroll from one to the next. So there is, but if you do that, then you've already defining the interaction pattern. Let's say, for example, if you applied a non-click listener to your buttons on TV, that already work with touch. So you can build some, interchangeable aspects of your application between your TV and app, between your tablet and TV app. One thing that I would say changes a lot is the look and feel of the application. When you're on TV, you want something that respects the 10-foot experience. So you need to have very big images. You need to have very big text. And on a tablet, which is going to be much closer to the user, you might want to rearrange those items differently. I don't know, Anish, if you have any additional tips in this sense.
Yeah, no, I think you covered it, to be honest. I think we have a follow-up question, is that so if we transfer an app from tablet to TV, there could be a way for the app resolution to respond dynamically.
From tablet to TV, there could be a way for the app resolution to respond dynamically. Well, yeah, I think if you want to do that, you need to make sure that you are covering the TV experience, which is you could potentially provide a layout that is only for TV and have the same app. A lot of developers do this, actually. They have the same app, the core app is the same, but then the layout look dramatically different for TV and tablet. So it can scale gracefully if you're on TV.
Yeah.
I would say that the safest approach is to have custom UIs for different applications, like even the type of views and activities that you display, or even if you're using fragments, what fragments are you using in your application? It will likely be very different if you're on tablet or on a TV application, but you can do this by all means if you want to, and if you have a good solution to describe, a layout for tablets that scales gracefully to TV, why not?
I think it's also very similar to how we see websites on a screen to on a phone. It's how we would take that learning. It would be very similar. How does an application scale from a huge screen to a tiny screen on a phone? Usually developers do consider things like accounting for widths, accounting for maybe stacking your items. You can do this very similar things.
Yeah, there is actually a good call out as well that says, I think you must also change some things in the manifest. For example, touchscreen off. Yes, that is if you want to say, okay, this APK should not run on a tablet, you should say, okay, touchscreen off. So that means that all applications with touchscreen will not fetch this version of the app.
Yeah.
So you can use these additional steps to make sure that you're kind of gatekeeping the different versions of your application between the different devices. Great.
Well, we don't have more questions. We can introduce next week's topic.
Yes. So Anisha, go for it.
Yeah, so next week we will be talking about optimizing Amazon Fire TV apps for performance. So we talked a lot about designing these applications, but how do we actually optimize their performance? So we'll be looking at some of the developer tools we have, such as Systems X-Ray, and how we can use this to look at things that we might not potentially see on an emulator to optimize our Fire TV applications for performance.
Yes, so a lot of good stuff. We will dive deep into the developer tools. You will see a lot of what's happening under the hood with your Fire TV. So a great session again here next Tuesday, 6 p.m. GMT, 10 a.m. PST. Did I say that correctly?
Definitely, yeah.
Oh, actually, maybe now that I'm thinking, it's probably
clocks are changing.
There is daylight saving this week. So this and next week, I think it's actually 9 a.m. PST, something like that. I might be wrong.
They really need to get rid of daylight savings, don't they? It's just so complicated.
I think so. It just complicates things. So let's just say 6 p.m. GMT. Of that, we're sure. Use that whatever time zone you're in. 6 p.m. GMT will be live.
Yeah. The only one
Wonderful.
time I
Anisha, as
appreciated,
usual. Yeah.
yeah. No, I was just gonna, I'm
No, no,
just,
go on,
no,
go
no,
on, go on.
it's not relevant at all. I was just gonna say the one time I appreciated daylight savings was there was one time I was at a concert and the clocks changed and we had an extra hour of the concert. So sometimes it's useful.
Ah,
Yeah.
that's great. I actually like it because our team members in West Coast are, closer to us for once,
Yours
so
is so much more
we can.
wholesome than my reason.
I know we can end meetings earlier, which is something I like. Only for a couple weeks a year, but whatever, I'll take it.
Yeah. Well, if you haven't already, you can contact us on our Twitter handles right down there and follow our socials up there.
I will get it. I will get it right sometime eventually.
There we go. But if not, see you guys next Tuesday.
Thank you, guys. Thank you for staying
Bye.
with us. See you next Tuesday. Bye bye.